Hi everyone, it's me, Mr. Ryan, and I'm going to use this video to go over population equation practice. Now, the front side of this assignment was actually really good. Very few people got questions wrong, so I'm not going to go through those question by question. I feel it's a waste of everybody's time. However, the back, not great. So I will go over those questions with a little more detail. So I'm going to share with you guys my screen so that you guys can see what I'm looking at here. And there you go. So this is what you guys should have, and these are the equations that we worked with. And what I would like to do is right now is kind of go through the front page really quick. So if you don't mind, I'm just going to scroll through. Now what you can do is you can pause and look at the work. But for the most part, I probably wrote in the comments of your Google Classroom whether the things were right or wrong. So ready, first one up. Again, most people probably don't need this. I'll move this out of the way. Is the population density one. The big thing for this, I guess, let me get my little pointer here, would be the fact that it was 5,000 square meters because the fact it was a half-hectare plot. Most people got that one right, though. This is the next one. In order to find the bagworms in a 200-kilometer square chunk of land, which is a very weird, if you take a look at this, I mean, this is a very odd rectangle of land, super thin and super crazy extended out. So I just did some cross multiplying. It makes sense. If there's 45 in one, we would have 9,200, okay? Made the writing a little bit thicker here so you guys could see it. Take a look at the birth and death rates for this aphid population. They're all right there. The only one you might have missed, and I should probably draw your is this one right here. A lot of people put the birth rate as being 0.04, and it was really 0.02. So if you take a look, that's what you're going to see. Okay. This is the questions for the bottom of the page. And if you take a look, the per capita growth rate was already shown for you. And we're just using registered nurse, which is RN, for that population. So then flip to the back. Hopefully I didn't take up too much of your time because the back, not so good. Okay, so if you take a look, and I'm going to just make sure I can get my pen going. They give you a deer population, and they tell you that it's 1,200, and 720 were born, and 240 died. So what we have to find here is R equals B minus D. That's our growth rate. Now our growth rate is going to be interesting because it's going to be this 720 divided by 1,200. And we are going to have 240, divided by 1,200. So when you actually do that math, I apologize that everything's written so terribly. I believe the first part ends up being 0.6, this ends up being 0.6, and this ends up being 0.2, I think. I don't know, I should probably punch that in a calculator to make sure. Give me 1 second, okay? You're probably like, I know it's already done, be more prepared. Yeah, it's 0.2. So the answer for this is going to be 0.4. Now that's going to be our R value. So at the end of year one, what's going to be the total population? So we're going to use this equation, registered nurse. So the registered nurse population is going to be, that's my dehumidifier going off. Hold on 1 second while I turn that on. For the love of God. Okay, sorry. It is going to be 0.4. You can tell it's my first time doing this kind of stuff, times the 1,200. And if I type that in the calculator, I end up getting 480. Okay, and that's how many should be, well, that's actually not the correct answer right now because 480 is how many we're going to go up. You have to keep in mind that we still have to add that to the 1,200. And I'm going to actually flip my computer. I hope you don't mind. I'm going to flip my computer a little bit so you can see my drop tile ceiling, my basement, just so I can write a little bit easier. Okay, you can still see my disgusting face down in the corner. Okay, so that ends up being actually, oops, it's kind of a train wreck, huh? Okay, ends up being 1,680. Okay, so the next one's really challenging. A lot of people got this one wrong. What would be the total population after 2 years, assuming that the R value stays the same? Now, just to make this a little bit cleaner, I'm going to circle this as an answer, and this is an answer for questions 8 and 9. And I'll make question 10 a little bit of a different color. So question 10 is going to be RN. You can hear my son upstairs yelling, "Mommy, watch this," because he's very proud of the fact that him and Emma are kicking butt in Lego Marvel superheroes upstairs, which normally I'm playing, but whatever. Okay, so if you take a look, the way I set up question 10 is I used the value that I got from question 9, because keep in mind that we're going to do this for 2 years. So when you do that, you end up with something like 670. When you're like, well, we're done. And really, you're not. You have to add that value to the original list. So it ends up giving you, and I have like no room over here, so I'm just going to put it right here, 2352 ends up being the population. So if you're wondering, well, how did I get question 10 wrong? And lots of you did, is because you probably used, I think what people did is they added like 672 twice, not realizing that the population is going to go from 1200 to 1680 to 2352. And again, the reason why that works the way it works is because of the fact that this value here has to be moved over. Okay. Oh, Matt's really getting excited upstairs about, I don't know who they unlocked. I think it was Punisher. Okay. So now if you're taking a look at this next one, which again, a lot of people missed, don't feel bad. It says, Kentwood, Michigan has a population of 49,000 people in the year 2013. The infrastructure of the city allows for a carrying capacity of 60,000 people. And thank God they give us the R max value, so we don't have to go figuring all that now out. So what would be the population? So what we're going to do here is a little something different. We're not going to put down just RN, because now if you take a look, what we have is a carrying capacity. So we're going to have to use this K minus N over K. So a lot of people set it up correctly by saying 0.9, and we're multiplying that by the 49,000. And I got to be very careful the way I write. But then the way you set this up is you're going to put down 60,000. And it's going to be really hard for me to fit this because I'm, you know how I am with these things. Okay, that says 49,000. And that's going to be all over 60,000. So I'll just get rid of, oh, that's not what I want. Again, that's 49. I should put down 49K. Whatever. It's supposed to be 49,000. So when you do all that work, what you end up getting is a value of 8085. And I rounded up to the nearest person. And the reason why I did that is because it makes sense to have a whole human being. And I think it comes out to like 84.99 or something like that when you do the math. But again, the part that a lot of people were missing, I think, on this was this part that the most important part that you are missing is the part that's written the most disgusting. So it should have been a 60,000 minus 49,000. So it ends up being like 11,000 over 60,000. And that gives you like a 0.183. So when you multiply that 0.183 times the 0.9 times the 49, 1, 2, 3, you get 84. So the next one says, what will be the total population size at the start of 2014? Well, we know that we are going to have 49,000 people, and they are going to add this number that we got. Take a look right here. We're going to add that to the mix, and that is going to give us a value of, altogether, I'll just take a look, 57,085 individuals. So is it above or below carrying capacity? Let's check out the carrying capacity. Carrying capacity is 60 grand. So we are under. Okay. How'd that go? Chances are if you had a problem, is right here in this part that I just moved, right here. Okay. Last questions, or last set of questions. Thank God, you're probably thinking, thank God. It says one dandelion plant can produce many seeds. Now that right there in the beginning is a huge hint right there to ease it's supposed to ease your mind. It says leading to a higher growth rate for dandelion populations. Makes sense. Dandelions make lots of dandelions. Population of dandelions. Ooh, take a look at this. we are sitting at 40 individuals, and the R max is 80 dandelions a month. So some people are looking at this question like, whoa, whoa, whoa. So far, all of our R values have been like 0.7 or 0.02. Why is this 80? Why is this value so high? Because consider the source. It is a dandelion, and dandelions can have lots of babies. So if we do registered nurse, we're actually going to put in a number of 80. We're going to multiply that by 40, and that gives us, I believe, 3,200. And a lot of people are like, I had that. How come in my Google comments you said I was wrong? Because what would be the total population after 1 month? Well, this is 3,200 that it should increase. Keep in mind that we started at 40 individuals. So guess what? It's not really 3,200, really 3,240, right? So a lot of people missed that. So when I saw the 3,200, which a lot of people had, I felt good. I was like, oh, they figured it out, or copied it from somebody, but somebody figured it out. But the reason why a lot of people still got a comment is because they just got the population. Okay, if we come over here for this other one, they tell you big news in this one is that now we have a carrying capacity that's 70 dandelions. So now what we have to do is we're going to do a little something different. We're going to have Rn, and then we have that crazy K minus N over K, which is going to be, it's the same as above. It's 80 times 40, and then, oh God, here's what, whenever I do any kind of equation that involves this carrying capacity, I start writing absolutely terrible. Well, you know what I'm going to do? I'm just going to put this 3,200 because I know that's what the value is from up here. I know that's what it's going to be. And then inside here, I will put down the 70 minus 40 over 70. And when you do that, you end up with 1371.4. And some people are probably like, Mr. Ryan, I wrote that down, and you said I was wrong. You said it in the Google comments. I don't know what I'm talking about. Right. Because again, same as before, when they say, what's the total population? You forgot the 40 we started with, meaning it ends up being, let me just move my face over here. It ends up being like 1411 or something like that. So we've learned a couple things today. Population genetics are pretty challenging, and I'm going to draw terrible with this. So it'll be interesting to see where things go. I hope this was somewhat helpful, and we will talk soon. I will start posting some other videos going over parts of the orange packet, stuff that we haven't learned yet, and stuff for the purple outline, because those two things were the ones that people wanted the most of. All right, miss you guys. Talk to you soon.